Frequency modulation, lesson number 2. Power in FM signal is equal to the power of the unmodulated carrier. It is given by PT equal to PC, also equal to VC squared over 2. That means power in FM is distributed among the carrier and its sideband frequency. From here, total transmitted power in FM signal also equivalent to PC times J naught squared plus 2 times the summation of Jn squared, whereby Jn refers to the relative amplitude of the sideband and can be 1, 2, 3, and so on, which is depending on the modulation index. Please try to understand the solution for example 1 and example 2. There are two types of FM spectrum, narrowband and wideband FM. The characteristic of narrowband FM are modulation index less than 4, frequency deviation in between 5 kHz to 10 kHz, bandwidth in between 10 to 30 kHz, maximum modulating frequency is 3 kHz. Narrowband mainly used for speech and data and also for public service communication. The characteristic of wideband FM are modulation index greater than 4. Number 2, maximum frequency deviation is 75 kHz. Number 3, its bandwidth is 15 times higher than narrowband FM. Modulating frequency is in the range of 300 Hz to 15 kHz. Wideband FM is mainly used for high quality transmission like FM broadcasting and television audio. FM has many advantages as compared to AM. The first one, FM has better noise immunity. This is because FM operates at higher frequency than AM. When the high frequency is used in operating system, the immunity to noise is high. Number 2, FM system has improved signal to noise ratio. This is because the system has limiter that can reduce the noise level and improve the signal to noise ratio. Number 3, all the transmitted power in FM is useful because most of the transmitted power is contained at the carrier component. Besides that, the FM modulation process can take place at low-level power stage. Therefore, FM requires low transmission power as compared to AM. On top of that, there is no interference from the adjacent channel because a guard band exists in FM spectrum. However, FM has several disadvantages as compared to AM. The first one is FM requires wider bandwidth for transmission. This is because FM produces many side frequencies during transmission. Number 2, FM stations are more complex and costly as compared to AM. However, with the introduction of inexpensive large-scale integration of ICs, The cost of manufacturing of FM circuit is comparable to AM. The third one is FM has smaller coverage area as compared to AM. This is because the propagation of FM signal is limited by the line of sight. This table summarizes the 12 elements of FM as compared to AM. Now let's learn about phase modulation technique. Based on this modulation technique, the phase of the carrier signal is varied by the amplitude of the modulating signal. However, the amplitude of the carrier signal is remain constant. In order to analyze the PM signal, let we consider the carrier and the information signals as below. The general expression of PM wave is given by V Pm of t equal to Vc cos omega ct plus phi. Phi is a phase constant which is directly proportional to Vm of t. Therefore, phi is equal to k Vm cos omega mt. K is the proportional constant. From the equation, Kvm is equal to delta phi. Delta phi represents the maximum value of the phase change introduced by a modulation signal, and it is proportional to the maximum amplitude of the modulating signal. Delta phi also is called PM modulation index. The modulation index for PM is greater than negative pi, but less and equal to pi. By substituting Kvm with Mp, the final expression for PM wave is equal to Vc cos in bracket omega ct plus Mp cos omega m of t. This figure illustrates how the PM waveform is generated based on the phase change of the square information signal. Let's learn how to sketch the PM waveform. Consider line 1 as our reference. From here, the amplitude of the modulating signal has changed from positive to the negative side. Or, in the other words, the phase of the modulating signal is changed by 180 degrees. Therefore, the carrier signal will change accordingly. By looking at the modulated signal, we can see that the phase of the carrier signal is changed or shifted by 180 degrees after the reference line number 1. The phase of the carrier signal will continuously change if there is a phase shifting in the modulating signal. This figure illustrates the comparison between AM, FM, and PM waveforms. By using AM technique, the amplitude of the carrier signal is changed proportional to the amplitude of the information signal, but its frequency remains constant. In contrast, if you use FM technique, the frequency of the carrier signal is changed at a rate equal to the amplitude of the information signal, but its amplitude remains constant. In PM technique, the phase of the carrier signal is changed based on the phase of the information signal. At the end of this lesson, students should be able to achieve all the following outcomes. Thank you.